All right, okay, that's gonna be fun. I wasn't expecting so many people, but I'm so glad I'm here. It's my first time at Devoxx Greece, not the first time in Greece, of course. As you know, I'm from Puglia, which is the southest part of a region of Italy. So we used to be the Magna Grecia, the big Greece. So we are connected to that, and of course also I have a beautiful connection to Greece because my wife is in the first row, and she's from Thessaloniki, so I love this country, and I hope one day to retire and come live here. So we're gonna talk about interesting topics. One that is particularly interesting for me, for sure, which is Kubernetes. I learned from my wife that is pronounced Kubernetes for real. So pardon me if I'm gonna just say Kubernetes all the time. It's kind of a Italianization of the word, but I know that is a Greek word, is Kubernetes, and I've been saying it for the last, I don't know, 11 years. So multiple times a day, and kind of I love the project and I love what it's about. So short about me, I'm Alessandro Vozza. I work at Microsoft, but these are not Microsoft opinion, of course. I do a bunch of things, including, and that's what I'm proud of, is my interest or work in the Green Software Foundation. So it's a foundation. I think you saw Josh's talk just before, classifying the languages by consumption and power efficiency. So that's exactly what the Green Software Foundation does. It concerns itself with measuring the impact of software, that's all we do, on the planet. And there is no highest or more important topic than saving our planet, right? So that's what I do. I live in Amsterdam, so if you ever come to Amsterdam, you're very welcome to contact me. I run the Dutch Kubernetes meetup, now renamed Cloud Native and AI, because of course it's 2026, AI is here to stay. So, and this is the talk where you can learn how the two words, right? So this 10 years old, mature, cloud native word interjects with AI. So first of all, who knows what is Kubernetes? So let's see some hands. Yeah, that was expecting. Who use GenAI every day? Like a AI coding assistant. See, almost the same people. Me, for sure. This talk has been done by me, for sure. It's the product of, I take responsibility, so if it sucks, it's my fault. But many images were actually made by GPT Image 2, was released, I think, 2 days ago. And I saw it, it blew my mind, and some of the pictures are indeed made by AI, and sometimes Claude. So I have to respect our AI overlords. Maybe one day they will be conscious and will come back to me and say, why didn't attribute this picture to me, because I made them. Now, this is more of a classic picture of what is GenAI and how it fits in the big picture. So we started, these things are not new, right? So we've been doing machine learning since machines appear, since they reach a level where they can be used to learn and to improve themselves. So machine learning is nothing new. It's been around since the 70s, and it's got pretty much a bit boring during the 80s and 90s. You know, there was kind of a peak, and then nothing really happened. We didn't. Well, yes, we of course we beat the chess masters at their own game, so definitely something was happening. Then for a while there was not a lot, and then in 2023, GenAI came to the scene of the world, and that's where we are now, right? So AI is becoming part of what we do as humans, and there's this interesting hybrid human-machine. We make code, we make pictures, we automate our lives. So it's a mind-blowing time to be alive. I'm very happy. I just turned 50, by the way, but I've seen quite a lot of revolutions and things in my lifetime, and I'm flabbergasted every day what I can achieve and what everybody can achieve with AI. So where does this AI runs, right? So, and that's where we're gonna talk about today. So this is the feedback loop. So the more we build, the more powerful it becomes, and we build more interesting things as we go. So AI is amazing. We need to run it. How we run it, and that's where we think about MLOps. Maybe now somebody talks about GenAI ops. It's about operationalizing these tools, right? So it's for us, for many of us, I put some message in a chat of OpenAI or ChatGPT, something comes out. What happens in between, right? So where does that text goes? How is decomposed? How is the model, large language model, think about that, and how does it come back, and why, and where is everything running, right? So now, big surprise, most of it runs on cloud-native infrastructure, right? So very famously, and of course, Kubernetes is the centerpiece of every cloud-native infrastructure, so it's a little secret. Many players in the market, from Anthropic to OpenAI, Microsoft itself, and many others, and AWS for sure. They build, they sell, they build products around it, they operationalize cloud native to run LLMs at scale. Why? We'll see it why in a moment. But this is what we think about when we think, oh, it's just a model. Yes, but there's so much in there, right? So there's a lot of data to be stored, all the weights, all the actual model that runs. You need to do inference. Inference is the act of sending a request to a model and get back a response. So typically when you chat with a chatbot, that's inference. That's where responses are generated. And then there is training, right? So the model is trained on a set of data and can be retrained, can be fine-tuned, can be you can feed new data. So these two things, these two operations, they are at the core of modern MLOps. Most of them, for sure, are in cloud native. So it's not easy, right? So if it was easy, everybody would do it. It's getting easier to do it on your infrastructure. I don't know, who runs models locally on their machines? A few, you see. So it's getting there, right? So machines are getting more powerful, like, so more memory, more CPUs, better GPUs, more efficient, consuming less. Models are getting smarter, smaller, and sometimes it makes sense to not pay anybody, but run it on your local machines. So this is getting more easy, but it's not there, right? So we are not just at the time where you can run a model on your phone, not just yet. So to run it at scale, to serve millions of users, OpenAI, I think, skyrocketed from 0 to 100 million in a month. How do you do that? You need to scale very, very quickly. You have to adapt. You have to run this GPU infrastructure at scale. And it's not a trivial task. It's not something you do just because it's fun. It is fun, but it involves serious infrastructure. So this is the premise, right? So deploying LLMs is hard. Kubernetes makes it better, like everything, right? So I'm sorry, I'm very biased towards Kubernetes because I love it. I've been part of the community for a long time. I just like the project, right? So there's many people don't agree with me, don't think Kubernetes is and it's not always the solution for everything, for sure. You want to run a simple website, Kubernetes is not for you. Don't even think about it, right? So don't run a simple website on a multi-node cluster. But if you want to do inference, if you want to do training, if you deal with machine learning models all day, that's the platform for you. And this was, of course, like recognized by the community, right? So I remember we were there 2022, 2023, 2022 started to really get more and more important. Of course, with ChatGPT, everybody was sold to the idea of running within the Kubernetes community also a working group for AI, a working group for inference, a working group for training, because that's how we do it in communities like Kubernetes, OpenStack, and so on. We just get together at conferences like this. Usually it's KubeCon or other conferences around the world, and we just get to talk. Somebody has an idea, and then we go back home and we start chatting over GitHub issues and pull requests, and lo and behold, something happens, right? So some people started to build these projects to run AI and machine learning workloads in Kubernetes. So it is difficult, especially because this is expensive, very power hungry, very difficult to run jobs. For example, training is a batch operation, so you need to run over multiple hours, multiple GPUs. It's not something you do just, it's not a one-off, it's more of an ongoing effort and needs scheduling, right? So the most interesting part of running these machine learning workloads at scale is the scheduling. And thankfully, Kubernetes is best at scheduling, right? So the scheduler is what makes Kubernetes really powerful, right? So is this ability to, this is ChatGPT, by the way, so of course, I told you, it's very good. This is the core of Kubernetes, is an orchestrator for workloads. Containerize, mostly, but of course, you containerize batch workloads, and there you go. You need Kubernetes for orchestrating these large jobs for AI and machine learning. It's not only that, right? So Kubernetes doesn't live in vacuum. It needs to interface with hardware, GPUs mostly, of course, but ASICs and TPUs and who knows what next is coming to the scene, right? So Kubernetes is an open architecture. It just doesn't work only with NVIDIA. If tomorrow you're running on AMD or these amazing Chinese GPUs, Kubernetes doesn't care. It just runs your workloads as needed. And on top, there's a whole ecosystem of tools, and we're going to look at some of them. And I'm going to show you what can you do when you have a Kubernetes cluster with a bunch of GPUs and you have a model to train, or you want to serve inference for your colleagues or your friends. Told you, not everything is good with ChatGPT Image 2. This is great. It's just too complicated, but it's something that I ask, make me a GenAI cloud native reference architecture, and it just put in all sorts of projects. I can zoom in, I think. Some of them we're going to talk about, and it's great because it's all in one slide. But if you have like me, you need glasses to see, then what's the point? So CNCF is very much interested in AI. Who has ever been to KubeCon? KubeCon, not many, all right. Well, I suggest you go because it's fun, it's a lot of fun, and it's a lot of AI, right? So it's that kind of conference. Yes, we talk about Kubernetes, but we talk about AI. So there is a Linux Foundation as AI and data landscape. Again, like it's just a bunch of big pictures with a lot of tools in there. You can see, and this, of course, is the CNCF cloud native landscape. Is what scares most people away, because do I have to learn all this stuff? No, it's just to show that the ecosystem is so vast that you need to you can't ignore it. Some tools that they are born and raised inside the ecosystem. It's not just Kubernetes, it's cloud native computing foundation, right? So it's not just one tool, it's just everything. It's things like KServe, and Argo, and PyTorch, and TensorFlow, and Kubeflow. We're going to show some of them now. I would like to, so I made a mistake in the beginning. I thought this was also a workshop. So I also would like to leave you with some practical examples. So Kubeflow is the workhorse of CNCF, of the landscape. It's been around for a long time, actually, since before GenAI. So it was born for running machine learning models, not only running them, so not only serving them, but also train them, do this thing called hyperparameterization and experimentation, so where you change parameters of serving and then see how it goes, and of course training, all done in Kubeflow. So open source, you can take it, run with it, don't need to pay anybody. So it's useful for model training when you have to orchestrate multiple runs of training. So you see every pod has access to its own little piece of data, calculates whatever, the weights, the vectors, and then put it back. And then Kubeflow orchestrates, thanks to Kubernetes, orchestrate the runs of this of training. You can use it for tuning. So this project called KEDA is like a sub-project of Kubeflow where you can just move around a bit of, you can tune a model for better results. So a model is always, is a static artifact, right? So you got GPT something, that's the training, right? So that's all you get. All you got from that model, the model is in fact like the sum of its parameters. But sometimes it's just not enough. If you ask a model that's been trained last year about something about the war in Iran, it's not in the training data, so it has no clue what to tell you. For the model, effectively, there was no war in Iran because the memory stops a year ago. So how you do that? You fine-tune it. You augment the base, the core of the model with extra parameters. And that's where KEDA comes in. I'm not going to show it to you, but you know, that's the architecture. And then KServe, Kubeflow was serving models pretty efficiently, but we needed something else, something more, because it was pretty limited. It was based on just Istio. And so KServe came to rise to become the de facto, in a way, serving framework for LLMs, GenAI, or whatever, in Kubernetes. So you see, it's a large project. It's comprised of multiple tools, including like Knative and Istio and so on. But the goal is to have inference. KServe is all about like serving models, so no training, no more focus, serving models out of a Kubernetes cluster. And you can see that because we love YAML in Kubernetes, of course, everything, we tend to express everything as an object. And in fact, this is the object that will create an inference service, and you can specify the model you want to serve, and a bunch of vLLM. vLLM is what we're going to talk about. vLLM is the workhorse of inference engine, and then you serve it through KServe, which is a very, very powerful. And in the demo that I'm going to show you, we're going to talk about KServe. Of course, why you run it in Kubernetes? Can you run it outside? Sure, you can. But what about? It's not the advantage of using Kubernetes. Is not just the scheduler. It's because now being a pod, right? So for example, in Kubeflow, these pods that run training, and in KServe, running inference. Being pods, they can be observed much easier than if they were running in an isolated VM somewhere in some data center. Being a pod means that you have a surface you can attach, I don't know, Prometheus exporters, and you can get the logs, you can orchestrate them and observe them as a unit. So this is important because whatever you do, if you don't observe it, it doesn't exist, right? So if you don't measure how many tokens you are generating, how many users you have, just doesn't matter to anybody, right? So Project Kaito, also from Microsoft, but now a community project. Again, like all these pieces, right? So there are people like, how can I start, right? So, and Kaito takes pieces out of many different projects, put them in a simple form, and makes an easy to deploy model in Kubernetes. I'm not going to talk about it, I'm not going to show it too much, but it is there too. For us, we've been talking about this, of course. Sorry, this is also when you want to serve. So serving is complicated, right? So because you can serve one model, right? So one model, one GPU, you put the GPU on, you put the pod on a node with a GPU. The GPU is given to the pod. The pod runs vLLM. vLLM loads the model, use the GPU. Everybody's happy. But that's not the end of the game, right? So sometimes large models, and we're talking about more than GPUs can have different size of RAMs, and sometimes the models don't fit in one GPU. Maybe you need more GPUs. Or sometimes the model fits in, it doesn't use the old GPU. So maybe you have A100 or B100. These are monster GPUs with tons of RAM and lots of computing power. And maybe you're going to serve just a small model. But what you're going to do, go to the data center and swap GPUs? It's not feasible. So there are ways to either serve multi-model serving, so get a big model, slice it, and serve it out of multiple GPUs. And there are also ways to slice a GPU and serve multiple models out of it. So, and this is only possible thanks to Kubernetes. No, not really. Yes, of course. It's possible because of the NVIDIA drivers. It's possible because of a bunch of things that need to happen, but especially it's possible because some people put some thoughts about these problems and say, okay, we got some work to do, right? So we got these small models, and then we waste GPU power. These things are expensive, and then on the other hand, we have these massive models, and they don't fit in one. So we need to make sure that we can serve the same model out of multiple pods, multiple GPUs. So this is not easy. It's model mesh, also part of the family of KServe, right? It's part of the bigger project called KServe, and that's how you do it, right? So you have this KServe, you put a service here, you create this. Most of these models, of course, are open source, because unless you have, I don't know, access to closed source models like ChatGPT and the family of Anthropic, you don't get to see them. But thankfully, we have an amazing website called Hugging Face, where you can just get this model running. And then once you get that, you get an endpoint that you can serve, that you can use you can give it to your AI coding agent, you can give it to your agents, and they can use it to run inference. In Kubernetes, no calls to anyone. You don't need, if you have a Kubernetes cluster with some GPUs, you don't need to pay anyone. Well, you pay NVIDIA for sure, and you pay the electricity, and you pay the cooling for sure, but it's still better, or it's up to you to think what is the best, if it's convenient for you to either pay per token versus running your own infrastructure. And it's becoming more important because sovereignty, right? So we would like to be more in control of what we do. As Europeans, as Greeks or Italians, we like to run things that are not, that don't have to go all the way to America for calculation. So and then this is what we think as a reference, the cloud native AI. This from a white paper, which is due for refresh. It's been 2 years already, which of course in AI geological age era. And so the basis is, of course, like Kubernetes all the way. Now, we talk about this. Kubernetes, of course, is evolving, right? So it's not just the scheduler, also needs some refresh, right? So before we were doing, just labeling nodes with GPU, and that's it. And then you could request a GPU when you schedule. But that was not enough, or at least not for advanced use cases. So the community came around a thing called dynamic resource scheduling, where you are a bit more flexible in how you schedule things. I don't want to spend much time because it also is in the hands-on, which I want to show you before we leave. vLLM. vLLM is a project which is not Kubernetes specific. vLLM is really the core of every inference engine you can see out there. You probably use it already without knowing if you run inference, if you use, I don't know, some models from, I don't think, of course, I don't know if Microsoft or Anthropic use it, but definitely if you are running your own inference, vLLM is the inference engine you want to see. So it's high throughput, it's very optimized, and especially as these very interesting features, which are now becoming more common. So he used the key value cache, so not every token, not every request will go through the whole process of retrieval from the core model, but it can be cached and retrieved from the cache. And that would be just much faster than regular uncached requests to the model. And then also things like disaggregated inference, which I think I have maybe a slide later. So vLLM, great. Now, how do you bring it to Kubernetes? Gateway API, who knows what Gateway API is? A few. OK, so maybe you know what is ingress. Ingress resources, they're all great, but they also evolved, and they evolved into Gateway API. So it's a way to bring traffic inside Kubernetes. That's it. So that's all you need to know. But of course, it's not only API traffic. It's not just your web request, right? So models are not APIs, right? So in this slide, you can see, so you get a normal request, right? So API, I want to know the weather. I make my post or get to http weather.com, and I get a response. And that's great, but it just doesn't fit the model of a LLM request. It's still REST. It's still post. I'm posting, I'm getting. The verbs don't change, right? So it's always a payload. I'm sending the payload. I'm getting something in return. That's great, but it's not just that. So now we think in terms of LLM-aware load balancing. So based on the actual request, based on where is this request going to end, we need to be more aware of where we are sending the request. So that's why Gateway API works awesome. It's great for regular APIs, regular HTTP requests, but GenAI inference extension are extension to the regular Gateway API protocol or specification. For example, they introduced the endpoint picker, where the gateway, the load balancer, can make a choice based on, for example, the key value cache usage, or there's no point in sending the same request to a GPU that is already busy responding to another request. But also, these requests are stateful, right? So if I'm talking to a model that is hosted in Kubernetes, and I'm making a request, I'm having a conversation, right? So if I now being redirected to another GPU with another, running on another pod, another node, I'm losing that context. So the Gateway API inference extension augment the Gateway API with this LLM-aware ideas. For example, I can also be routed to a lower model, as in maybe cheaper or more specialized for my request. But it's only possible if and when the load balancing, the API layer, understand the request. And before we were just saying, oh, just a request, just send it. The load balancing layer was pretty dumb, and now it has to be more aware of what's going on. And then we hit our endpoint, and that's where the fun starts. Who likes hardware? Who likes to tinker with hardware? They're so beautiful, these GPUs. They're just amazing because it's concentrated technology. It's mind-blowing, right? So I'm a gamer. I used to have like an actual GPUs. I still have one. Can buy more because, of course, they are so expensive. But these GPUs are just amazing concentrate of technology, and especially the new ones are mind-blowing, and they just a bit hard to make it work, right? So there's a driver, there's an interaction of many layers, and it's just one, right? So there's a big CPU, GPU with a ton of RAM on it. What you do if your model doesn't consume all the RAM, then you do this thing called multi-instance GPU, MIG. This is done by the driver, but Kubernetes needs to be aware that what was one GPU now is 7 GPUs, slice of each. So this is also why we have Kubernetes, because in the end, Kubernetes orchestrates and manages these layers of GPU. So it's just a stack, right? So and you need to understand end-to-end the whole stack, and that's important. And this is what we call it. So based on the prefix of your prompt, you have to be more aware of where you're serving. And finally, of course, this is what we talk about. So you got a client, your phone, your chat. It goes to an inference gateway, so this with the extension, and then it goes to a pool. The pool is made of vLLM instances, of course. But that's not enough because there's this shared cache between all the instances, and this all needs to be managed and orchestrated by Kubernetes and all the tools around it. Now, in the last 10 minutes, because I really thought this was a workshop, so I prepared something, right? So, and you can scan this. It's a platform online. This was made by ChatGPT, of course. Because all these things we can talk about until we are blue in the face. I think we have like less than, how many minutes we have? I don't know, like let's say 5, right? So let's say that we have 5 minutes. So if you scan that code, let me make it better. Let me make it. Whatever. I mean. So if you go to this platform, I use it because it's great and it lets you create these workshops. So this is it's no better way to learn than just get your hands dirty, right? So I thought this was a technical conference. So let's get technical, right? Let's go full screen, maybe. Let's get technical in full screen. So I know not everybody knows kubectl and Kubernetes, but it's also a way to learn. By the way, on this platform, you just need your GitHub account, and there's tons of tutorials to learn Docker, to learn containers, Linux. Please go. It's personal. I mean, it's somebody, I wouldn't call it a friend, but he's a good acquaintance of mine. He lives in Amsterdam as well. Alex, he's super cool. And he built this platform from scratch. So if you wait just a little bit, the playground will be loaded. Yes, there it is. So what it is that you get instructions on the left, and you get the tutorial on the right. I don't think you can swap it, but I hope you don't mind having right and left. And then of course, this is a, so do I have a GPU in there? I don't, of course. Like, I mean, the guy is very generous, the Alex from the platform, but it doesn't have GPU lying around for me or for you to test, right? So this is just a regular 3-node Kubernetes cluster, but there's a project called Fake GPU. It's real. And I'm sorry I have to look there because I don't see it here. So first of all, we need to install Cert Manager because this fake GPU operator needs certificates to operate, of course. But this is so cool. So first of all, we make sure that, so you can actually try your GPU workloads even when you don't have a GPU. You need to make sure that you don't have the runtime class. It's something that maybe people don't know, but it's a way to specify a type of runtime. So you can say this workload, this pod, we run, for example, on kata containers or another type of runtime. And we have a runtime called NVIDIA, which shows that we now run NVIDIA, like CUDA and so on. And if you can get pods, you can see there is this GPU device plugin and the fake, the topology server and so on. So now that the operator is installed, right? So we need to tell which node we'll have this fake GPU. So we label the node, and then you can say kubectl get node show labels. Show labels. Minus. Tell me if I am typing something wrong because I'm almost blind here. Get node. So, and then you see that the node 01 should have a label of type GPU. NVIDIA GPU, deploy, so on and so on, and then you can see why you get, I mean, you see that because I label it now, my scheduler is aware that there is a node with a GPU. So if ever I need to run a GPU enable a pod that needs a GPU, I can do it. I'm going to do it this just a few things. So yes, and then I can see there is a capacity NVIDIA COM echo 2. And now I'm going to schedule a pod. So I'm running a GPU test that the image you see is BusyBox, and it just runs on GPU. Normally, if you don't have a GPU, this pod will not be schedulable because it requires to have a GPU. But you see that now you get a pod. You get, like a pod is running, and do we still have time? 1.5 minutes, wow, we can, it takes a minute just to pull this Olama image, but the idea is that once you run this, so this is Olama, right? So Olama, you can run it on your laptop as well, just another inference engine. It will also pull, you can pull this tiny llama. It's a very tiny, so it's still CPU, no GPU involved. It will pull this tiny llama model, super tiny. I mean, it does really almost nothing. And then you can ask, oh, tell me why Kubernetes is great for AI, and it's going to respond to you. But it works, trust me. And please go to the demo, use the platform, give us feedback to the platform and to me, or please send me a message if you get your phone out. Yes, all right. You got 30 seconds, 29, 28, okay. All right. You have a reason to send me a message on LinkedIn if you missed the QR code. Thank you so much. I hope it was informative.